The cyber part of this CPS is actually governed by an MES, or Manufacturing Execution System, which is installed on the server. So the screenshot of this system is shown here. The MES system obtained the process planning of the order from the upper level, which is the ERP, or Enterprise Resource Planning, and then dispatch this process information to the machines on the shop floor through the agent ID. So the processing status on the shop floor was updated to the MES through feedback from PLC, as you can see from the screenshot here. The cognitive agent, as we know, is installed on the PC. So the screenshot of the machine agent is actually shown here. Okay, so the machine agent decides according to the disturbance type and recovery method. We can see from this screenshot that we have the main window on the left that describes whether the machine should negotiate or reschedule based on the disturbance input. In this case, the agent recognizes the status of the system through the signal from PLC, which is basically a toolware or tool broken. And then, according to the disturbance input, the agent uses a search method through the SQL query to match the disturbance database with the current disturbance signal. So the agent will then self-adjust based on the processing information database. So the database will always be updated using neural network to have the exact cutting parameters in proportion to the toolware. So the interaction between agents was done by the message processing. Okay. The response time in this case of disturbance include the data transfer time from the manufacturing execution system to PLC, from PLC to PLC, and from PLC to controller devices. And we can see that it will increase depending on how much negotiation that will take place for the process to be fully recovered. Okay. All right. So if we look at the model itself, we can actually generalize this concept to a high-speed machining in the factory. So if we take a look at this figure, it shows the disturbance classification by which disturbance were sorted into internal disturbances and external disturbances. Okay. External disturbances are related to an order change or there is supplier problems. Other disturbances such as tool wear, incorrect process, and so on related to the physical system, process, and services. Okay, so these disturbances were recognized by their symptoms here. Okay, so the symptoms are used to the symptoms are used for developing the rules or reasoning mechanism in prediction for the CPS to find out the disturbance. Okay, so according to the disturbance classification, the database for CPS, including information such as resources, disturbance, and the recovery method, can be developed. Okay, here. So if this model is in action, the perception module will collect data on the shop floor. Okay, so you will get all the process information. And then the disturbances such as the high temperature of oil or cooling system could be recognized directly through the change of data value assigned in the database. Okay, so some disturbances require the use of pattern recognition algorithms such as artificial neural network to recognize the disturbance. So in this case, the perception module was extended to diagnose the disturbance. So during the machining process, cutting tool where it directly impacts surface roughness. During the machining process, okay, cutting tool which directly impacts surface roughness is a key factor in determining whether the machine parts meet specifications. So normally the cutting parameters used is optimized before machining. Okay, so with CPS, we are able to have a dynamic optimization, which can be done on the fly by predicting tool wear using artificial neural network as the machining progresses. So this will optimize the output of the process. Alright, so by now, I hope we already have some gist on how CPS can work in manufacturing system. And more importantly, the adaptation of a manufacturing system to disturbances, which enables the system to respond rapidly and to recover autonomously, will help the manufacturing system running and avoid it from stopping completely. So this will be key to ensure that we have optimized the production and cost as much as possible. And I hope that I have made it clear that the difference between CPS and the computer integrated manufacturing. So computer integrated manufacturing activates automatic operations using a pre-instructed programs, and they should be stopped to reprogram and replan in case of disturbances, because we have human as a decision maker in that system. And then because of this characteristic actually reduces the flexibility of the system and increase the downtime. Okay, so this will be the end of the lecture on a cyber physical system in Industry 4.0 context. So I hope that we can have some sort of enlightenment on how important mechatronics engineers in this setup. Okay, you can see that there are a lot of knowledge or engineering knowledge that you need to have to actually goes or work inside a CPS, and that includes all the programming that understands how the database works, and also you need to be able to work on different communication protocols, and as well as understanding how the controller actually works. So in this case it's a PLC. So we have now done the PLC programming and so on, and we can see that although we have worked on a lot of cases that estimates what should be done when there is some errors here and there, we have learned that through the PLC itself on its own it cannot do the decision making unless we pre-program it, right? Okay, so now we know that decision making can be done if we connect the PLC with a PC that have cognitive agents inside. All right, so to establish the CPS itself, I think mechatronics students have ample knowledge, or the breadth of knowledge that is needed for the system to be set up. And it is important for the engineer to understand how system integration is done in a CPS, so that we can actually propose an appropriate CPS for the manufacturing system.